I don't know her well, but she's been recommended to me by so many.
Requirements engineering, that's a subfield of software engineering, which one could argue has completely gone out of vogue because of the things I'm going to tell you in a moment. And I do work at the intersection of privacy-enhancing technologies and security and software engineering. And most specifically, the work that I try to do is to ask, what is the problem that we should be solving? And do we have the technologies that say that they are solving these things? Are they really solving these things? So like, these are the type of questions on a very high level that I ask. Today, I'm going to take on the task of the title of this workshop, although I say beyond differential privacy, but I think the question is not just about differential privacy, but also is there maybe something we should be looking at beyond privacy? And specifically, I'm going to propose looking together at something that we call protective optimization technologies, and that is a play on acronyms. Privacy-enhancing technologies is what I work on. There's a whole community. It's called PETS, right? And this is, if you look at the acronym, it's POTS. Okay, so about the talk, I have a lot to say. So what I've decided to do is I'm going to shorten Act 1 and turn it into a prelude. And I hope that if you have issues with a prelude, that you just hang in there, because I'm just going to go really big, because I'm going to say the world changed. I'm going to describe a new world. And then I'm going to be a little bit more specific, and the most interesting thing comes in Act 4. So the more questions you ask here, the less likely we get to this. So it's a trade-off, okay? All right. So let's start with the prelude. So the question of the prelude is privacy what is still at stake with the new kind of systems that we have? And to kind of answer that question, I'm going to start with this very famous sentence. Some people say it's the World Economic Forum. There are articles that show that it has been used many, many times, that data is the new oil, okay? And data as a new oil has often been translated in privacy communities as data is the way in which these companies make money or value, right? Like they extract and exploit data, and that's why we have like all of these very, very rich companies. In fact, there's another interpretation here which adds that it's mainly about personal data or behavior of people. And that actually takes a lot of the research community into doing research on the data broker industry. And here I don't mean just like the companies that we call data brokers, but we can also see Facebook and Google as data brokers in that sense. And also looking at, the way in which data is useful for making revenues through profiling and, for example, targeting ads. This interpretation brings us to looking very much at consumption of technology, but it doesn't make us look so much at production of technology. In business terms, we look at business to consumer relationships and how they affect people, but we don't look so much at business to business relationships. Okay.
Sorry, this is just vocabulary that I don't understand.
Yes, okay.
Can you do that again? The last line.
Absolutely.
What is consumption? What is production here?
So basically, we look at a lot of the problems that appear on the interfaces that we look at. So we look at things that, people get advertisement, people experience a decision, they actually embody experience it, but there's a whole technology infrastructure that brings that interface to us. And we don't look at that. It will become a little bit more clear. And because I'm into software engineering, I'm going to look at the production of software, okay? So I'm going to not start with data, but I'm going to start with computation and software. So when I look at production, this is what I see. And now it's your turn. What is going on here? Who knows what's going on here?
Microsoft with the launch of Windows 95. Launcher.
Okay, people that answer quickest are the oldest in the room, okay? I'm sorry. Like, maybe not, but this is a good way to rethinking age. All right, so basically, this is the era of what is called shrink-wrap software, and the reason it's called shrink-wrap software is that when you develop it and have a release party, so this is a release party, Windows 95, I think, starts around 92, and it actually releases in 95. You put that software on diskettes, depending on your age, on CD-ROMs or on DVDs, and then you put it in a box, and then you put a shrink wrap around it. That shrink wrap seems kind of trivial, but in fact, when you break the shrink wrap, you enter a license agreement with the company that sold you the software. So it's very important. Okay, Microsoft made a lot of money from the licensing of its software, from the sale of its software. However, those days are gone. Like Windows as a project has been killed. Microsoft is no longer a software company, it's a cloud company. And that happened because in the last 20 years, we went through these three transitions and many others, but these are the three I will be focusing on. One is from the box software that you release and you can't change anymore so easily unless you release again, to services, which means that the code base remains with your developers, right? And that's really exciting because now you can develop software incrementally instead of working on it for 2-3 years. You can have a minimum viable product. You can put out a feature, and then depending on the interactions of the users, you can develop new features. And because it's services, you don't develop everything monolithically. You can actually integrate third-party services. You can do one thing really well and take everything else from everywhere else, okay? And it's really efficient, it turns out, to do this on the cloud, but I mean, basically what the movement that is going on here is that instead of people installing software on their devices after they open the box, you now can just basically get services from the cloud. I can talk about this for hours, but because we have a day to finish, I'm going to say that this thing that looks like a trivial move in software engineering, which had immense benefits for software companies. It used to be 70% of software projects failed. And with Agile and the move to services, that number is reduced. Maintenance costs are reduced, and a lot more money is made, and a lot more flexibility is produced, and a whole ecosystem is produced, right? Like we have the service ecosystem. And data plays here an important role, right? So no longer are these software companies just looking at data as something they would give to advertisers. Let's say this is a software ecosystem in mini form. These would be the advertisers. But they also use the data to continue to get feedback on the features they develop, to get feedback on the services they integrated, and to get feedback on the use of computational resources. And in fact, for many of the people in the business of software, where money comes from is being able to scale your product without increase in your computational costs. And here the clouds come in, because what was one of the biggest costs for software companies was basically, let's say, investing a lot of money in your IT infrastructure. That would be the computers, the servers, and also your sysadmins. We had a lot of sysadmin jokes when there were so many sysadmins. But now what you do is you rent those services from the cloud. So what that means for companies is that instead of sinking money, which is called a capital expense, you go into a rent mode and an operations mode, so you make operational expenses. You don't need to understand very much of this, but what is happening is that the clouds are not just an infrastructure for computation, but they are the promise that you can make a lot of money by taking all of the money that would go into IT infrastructure for every organization and centralizing it in the hands of a few companies, right? So what happened with advertisement, where we had a few companies make a lot of money because they took everybody's advertisement budget, we now have a system which is saying, I will take everybody's IT money. Yeah, IT budget, that's a lot of money. This is the fastest growing, one of the fastest growing, most popular investment objects. So there's also like a huge financial interest in this. Data is important in all of this, right? Data is important in making sure you optimize your business, making sure that you have a good overview of your resources, and that you also are having cost benefits by using the cloud. So data is not just personal data, it is the oil that is kind of making this whole system function. It's not just a resource, it's also an enabler. Okay, what does this mean for systems? So before services, systems were kind of static. So you would make, let's say if this were a bank, you would make a model of the workflows in the bank, and you would automate or augment processes in the bank. And that would give you information, right? And the problems with the information systems were seen as like surveillance. You could now know things about the employees. You can know things about the customers. What we have now is a system that has feedback loops. It is developed incrementally. So what you can do is you can constantly optimize features depending on how people are using them. You can optimize your employees at the bank by looking to see if they're bringing enough profit. You can make sure that you optimize your business agility, right? So you can put layers and layers of optimization into the development of an organization using IT, okay? So this is a huge shift. So far with me, I hope. Okay, so what this means is that whereas here we said there's an issue of information, so we correct information and we have knowledge and we have surveillance problems, and the response to that is to provide some sort of privacy. Here we have systems that focus on optimization. They're not so much producing information as much as they're constantly adapting the institutions that they're in, right? So what are the harms of these systems, and what are the ways we can protect people from those harms. So that's Act 2. So the question is, are information systems and optimization systems really different? And if they're really different, are the set of harms that they bring along also different? So if I could define this in a very loose manner, information and communication technologies allowed us to store, process, communicate, and share information. It had a kind of knowledge claim, like we would know things because we'd be able to organize information in a different way. And it came with the problem of surveillance, the response to which was privacy. With optimization systems, we have the feedback loops. So these allow us to constantly put things under the control of objective functions. And the promise they have is that they can capture information about the world and provide ways to manipulate it for extraction of value. Right? So I can know how the bank employees are working, how the customers are using money, and I can use that to optimize the inputs of the bank. Okay, so what are some of the known and discussed risks and harms when you take a system that captures and manipulates the world at scale, right? So this is now maybe a new set of harms. Obviously, if you have a lot of data about a lot of places, and this is not just personal data, right? You're collecting also information about environments and things like that. You have an intense amount of concentration of power if you've actually been successful. Social sorting is a term that kind of relates to fairness. It's basically saying you optimize for certain populations and some populations are not very optimal, so you sort them out. Then there's mass manipulation. I mean, we all heard about the election manipulation. So Facebook's basically engagement platform was used to center on fake news and was seen to be manipulating elections. It leads to majority dominance, minority erasure, and I'm pretty sure the list will go on as we start to understand what these systems are causing in terms of harms. So when I asked the question, are these specific to optimization systems? Is this really a different beast? It's maybe interesting and provocative to say, even if you address privacy, all of these things would still occur. So to be even more provocative, if all of the machine learning and all of these systems were done with differential privacy, you would still have these harms. And this leads me to say that not only is the production condition very different than information communication systems, but the set of harms are also distinct from privacy as we know it. We can have a longer discussion of whether these are infringements on privacy as autonomy. If that's the right thing, I don't know. That's an open question. So now I want to go to the next step where I want to say, well, what can we do as computer scientists? Because this so far was very high level. So to make my point, I'm going to look at location services, which optimize transportation in different ways, like how do we get from A to B, Google Maps, Waze, there are many other companies out there. And to first give you a sense of the way in which we said optimization systems capture and manipulate environments, I want to just take a moment to look at some of the favorite games of some people. Maybe it's already out of vogue, Pokemon Go. It makes very clear the way in which these systems not only gather information, but they can bring crowds together. They can create geographies almost, right, that can be used to extract value. So you have the power to manipulate the environment and people in that environment to cause an event. That's what Pokemon Go is able to do. Waze is another example. I don't think I need to give the details because earlier this week we talked about it quite a bit. It's a crowdsourced traffic beating app, which makes money by optimizing also for the users the ability to get from A to B. Now one can say what could be wrong with this, but in fact scholars in Berkeley, lucky enough, did this study and showed that actually while Waze optimizes for the individual users, in the total of the whole thing, they make congestion worse for everyone. Okay? And so there's some very basic logic to this. I can share the article with you if you're interested. Where freeways and highways decongest, they're very much optimized for decongestion. So if there's a congestion and the blockage is removed, it decongests very easily. If you go to service roads and you have congestion, it's very difficult for that congestion to decongest. Okay? And so here we have a system, one could argue, that has an asocial goal or objective function. Which could be maybe relevant to all the discussions about is this a good AI or good machine learning project versus bad machine learning project. So one of the things that these systems do is optimize for a bad objective. Okay, but it doesn't stop there. It keeps on going. So as we know, Waze will route users to surface roads. And this has an impact on non-users and environments, right? Here's a case of a road in LA, which is rather steep. A lot of cars get diverted into this, and they don't come out, apparently. But also, the same traffic engineers showed that if only a few users use Waze, they benefit. But if everybody starts using Waze, there's actually anarchy, right? Traffic anarchy is, I think, what they're calling it. So they also often tend to benefit a few. Okay. So what I'm trying to show you these examples is to say, maybe we can use the language of optimization to come up with externalities that we can then address using computational abilities. So here's my first list. So we said Waze is, for example, disregarding all the non-users and the environmental impact of the application. They can benefit a few. They can have a lot of errors, right? You can have distributional shift. You train Waze for one place, and then you go to another, and it causes a lot of errors. There might be a decision about how you're going to distribute your errors. There might be exploration risks. And the point is that Waze and many of the companies that do optimization is they push the costs of all of these things on their users, on non-users, and on environments. So the idea would be, if that is the form in which these harms happen, is there a way to build technologies that internalize these costs into the company? Or if they don't do that, provide ways to protect the users, non-users, and environments? Yeah? I didn't expect you guys to be so quiet. So, okay. So one could say, but isn't fairness exactly a response to this? Yes, please. Oh, thank you. Yeah.
If the kind of the assumption that there's a price to anarchy is that there is no central coordination to this selfish behavior, but it's exactly the opposite of the assumption that everyone is using Waze.
But Waze is just operating to compute your best response right now.
For a single person.
It's like helping to find the equilibrium.
If Waze controls a significant fraction of the traffic, they're able to coordinate.
But if they're not finding your best response, then I'll use a different app that will.
But it's not what the assumption is saying. The assumption is that everyone is using Waze.
The assumption is not necessarily that everyone is using Waze. I'm not sure how you got to. Actually, one of the problems is it's very difficult for service providers to control the whole environment, and it gets even more complicated if there are multiple service providers in an environment, and therefore it's even more difficult for them to capture the externalities that they might be causing. So even if Waze took into consideration and managed sort of some of the congestion on the surface roads, by virtue of not knowing what the other companies are doing, it has limited information and limited ability. Does that help with the question? Yep.
But with what you just said, you confused me then a little bit. So what is the defining feature that you are concerned about, the centralization of an optimization technology? In which case, the fact that there are others who do the same thing would be a good thing, right? But now you said you could govern it better if you had full information.
I don't think that we have enough research to answer this question.
Right.
But I do see that centralization is an externality in and of itself.
Okay.
And then the question of multiple parties acting at once and causing mayhem because one of them will take responsibility for the combined effect is another problem. How these are related are great research questions. Yeah.
Okay.
But like the optimization here, like the role that it's playing is to sort of help people find Nash equilibria, and then somehow, we know that Nash equilibria can have a large price of anarchy in a routing game. So, but like, yeah, so it's a very interesting question, but it's like hard to push people to something that's not a Nash equilibrium, because if your app tried doing that, then there would be room for a new startup that would compute best responses.
Right, because so interesting. I think these are the kind of research questions I'm trying to dig out, first of all. And second of all, I think maybe there's an externality to be written here, which is that once you go into the logic of optimization, there's no logic other than that. right? Like this idea that maybe we don't optimize things, but we do something else sometimes, which have greater social value than optimizing for a company, is, seems to be maybe something we need to put as an externality, because it literally makes many people start counting numbers, like who benefits how much. Well, is that little disadvantage okay? It's it's optimal, et cetera. And the question is, should we really have that kind of thinking trump all other kind of value systems and reasoning systems?
But like, I guess the issue would be that it's sort of the market behavior that's doing this. Like if we mandated, right? Like if everyone had to use Waze, then Waze could start computing things that were optimizing for social welfare, but not for you. But because you have the freedom to choose which app to use, like
right.
Waze can't do that if they want to keep market share. Because if you start, if the app starts giving me instructions that cause me to do something that is socially beneficial, but like it takes me like 10 minutes longer to get to work, I'll start using an app that.
Or they can like use increasingly more complicated ways for you not to be aware that you're not taking the optimal route.
Maybe incentivize for taking a longer route.
So there are many different ways in which you can imagine addressing this problem. There was one company that I heard about which basically said we will not reuse residential roads, right? And that way they leveled the field for all the parties. And they said that because the field was not level, they did indeed lose out to Waze. So if that's your question, yes, that's an issue. So then the question is, how do we address these harms in a way that is fair to maybe market effects, but also society?
Aaron, you're jumping to the conclusion that coordinated national equilibrium is somehow not possible or socially not optimal in this case.
You mean a correlated equilibrium?
Correlated.
Yes, so correlated equilibrium is one kind of approach to this, because the price of anarchy can be lower for correlated.
That's right, and it can be national equilibrium under some.
That's right. But sometimes the price of stability isn't one either.
So, but yes, Niva.
So just like, if you can define more precisely what's wrong with optimization. Is it about who is doing it? Is it about how it is being done? Is it different from the way, government's also trying to optimize things. So if the government was use this,
Right.
is the question is what makes this a special case is that we optimize by a different method? Like the method of collecting information, the infrastructure of production that you have described is different, and therefore we need to worry, or is it about the optimization? Because the optimization maybe, if it's done by corporations, maybe they maximize profit, they don't take into account, but maybe we'll force them to take into account. We'll force everyone to use Waze. We'll have zero competition. Would that make the optimization optimal?
Right. So I think. So the market question I hadn't considered before, so this is very useful already. But the point that we're making here is that there's a higher level question of, is this a good goal or not? But these costs incur regardless of whether the goal is good or not. Right? So you can have an optimization system which has an objective function where you say, this is a great definition of social welfare, we should do that. It doesn't keep you from having errors. It doesn't keep you from having exploration risks. And the question is, who will take care of those costs? And what we know, for example, from Waze, is that individuals, communities, neighborhoods, municipalities have contacted Waze and gotten no answer, right? And so there's a governance issue here, so they do not respond. There's a governance issue also that there's no local liability maybe, so like there's all these like bigger questions that you guys work on. But there's also the question of like, how do we even notice the errors and the costs, and how do we even respond to them, which is very, very complex. Does that help a little? Yeah.
So I guess the counterfactual you are imagining, these costs are incurred relative to there being no optimization or there being a better optimization. If we outlawed all traffic information sharing at all, will all of these problems go away, or?
No, I don't think the point is that we should outlaw optimization. I don't think that's where I'm going. Although I think there are people, for example, if you look at the discussion around facial recognition, there are people who are saying this kind of optimization is not acceptable. So there might be that question at some point. But I think in this case, in the Waze case, I'm saying today that they're causing mayhem by introducing surface road traffic. But if you look at like the introduction of freeways and highways, they were absolutely like reprimanded and like said like they're awful and they're destroying neighborhoods and what have you. So I think what I'm trying to do here is actually say this is a very political decision that these optimization companies are making. They're using public infrastructures often, they're piggybacking on them, and yet they're not deliberating at all what are the values we're optimizing for. Yep. Adam and then Aaron, if that's okay.
I guess I just, in some sense, it's not like optimization is a new thing, right? We've been doing this.
Right, yeah.
So why is it that you feel that this is a qualitatively different phenomenon now than it was, 30 years ago, wide use of the internet? Right? Is it the fact that
600 years ago, the tragedy of the commons and the enclosure movement in the UK?
Right, sure. I mean, I guess arguably, like any kind of bad equilibrium outcome in game, like in a market or whatever, is like a result of people, of this kind of exhibits like, all of these problems.
Sure. Yep.
So so that's my what is it that you think of as the key difference? I can think of a few, but.
You want to think with me? Like if you have some ideas.
In fact, like one big one is that we're all using the same optimization software.
Okay.
Right, and so we're using the same information to optimize, as opposed to like, back when we had paper maps and we were all optimizing using kind of whatever crappy information was on the radio, and like just wasn't that good, and so we were kind of like, in some sense, had some randomization in our like behavior.
So I think there's like two things I will say, and I'm just intuitively saying these things. It's not like I have thought about them as much in depth. That's why I'm giving this talk. The first one is we can make the same argument for privacy. Like we had privacy issues before. There's nothing different about them with the introduction of information systems. That doesn't change the fact that we need to say there is a surveillance problem, or there is if you don't want to call it a surveillance problem, but something else, and we want to respond to that. So I think I'm asking, have we been looking at the harms of machine learning and optimization in a systematic way? And in fact, most of this stuff is from AI safety literature, if you haven't noticed yet, but most of it is said to be just accidents, and I'm just wondering if we can maybe be more responsible about these costs and do something about them.
Seda.
Yeah.
So, I do think, just going back to Neva's point, I think maybe part of the issue is, and in part you're using Waze as an example, and I think Lyft or Uber as examples, that there's a level of centralized planning that is being kind of slipped under, right, as though it's individual choices, but in fact it isn't. It is like centralized planning. And if you were, for example, while we can complain about the roads and highways and where they end up being placed and all of the problems with the process, there was a process that was supposed to consider multiple values, allow for participation, have oversight and accountability in a way that I think you're saying these systems don't, because it's a centralized planning process without any center.
I think that would be another one. Yes, absolutely. Absolutely, yes, that would be another one. I just wanted to also add to that it's not just the centralization, but the fact that almost they're going into every sector and every activity, right? Like including how we communicate with each other or whatever. So that's, I think, like there's a qualitative difference, maybe not, yeah.
So just to pile on, I guess, because you said you wanted more people to interrupt your...
Yes. I want to get the pots though, right? So.
But like to follow up on Kunal's point, not that not that your proposal is to outlaw optimization, but like it seems to me as a thought experiment, if nobody was using any kind of optimization software, many of these problems would still exist. Like in particular, if you think about like distribution of errors and exploration risk, like the examples people usually use are, okay, I've got to drive to the hospital, I shouldn't be the person that's used to like explore. But you'll have different populations will have sort of different familiarity with the road networks and traffic patterns in different parts of the city. And so sort of the lack of optimization will exacerbate the sort of information disparity that different populations have. And so like, my first like reaction would have been that something like Waze actually, of course, these concerns are all there, that for many of them, I mean, obviously not mass data collection, but for many of them, it's ameliorating these things compared to what would have been the case, like, in the absence of information or
Right.
optimization.
So I think like one critique of our work is like, what is the starting point, right? And I think that's one that we're still grappling with, because it does mean like, let's start, like there, at T0 there was no optimization, or there were other forms of optimization, and now we added another one. How do we deal with that? And I think this is something, again, like it's a question, how do we model these things? But maybe one of the important points I'm trying to make is that it is not sufficient to just look at the machine to address some of these issues, but we have to look at the environments that we're in. And I don't know that we're equipped right now to have the way to model and look at those things and understand the kind of delta between, you know, environment without and environment with the system, and how do we evaluate that difference? So yeah. Julia?
I'm still thinking, sorry.
No apology. No, like, should I go on? Because like I'm just looking at the time. Shall I continue with? Yeah. Okay. So one could argue that fairness deals with these issues, and I think this might maybe help with trying to see what the difference is between the optimization harms and fairness. First of all, fairness is not the only externality, although of course, like as soon as you talk about risks and costs, they're not equally distributed across society. So the more costs that you externalize, the more likely you're going to hit certain populations more than others. But what is also interesting about a lot of the work in the fairness framework is that you assume a trusted service provider. So we assume that the service provider has the incentives to recognize and remedy fairness issues. And as somebody coming from the pets community, the first thing we do is say, what happens to the world if this assumption is not true? And that's what we do in our POTS work. The other thing that I think this community might have something to say about is that not only they may not have the incentives, but they might also not have the means. So if there are, so to say, multiple optimization companies working in an environment, they might be causing something that none of them can readily be able to foresee or be able to do something about. And the important thing about the difference, again, is the decontextualization, whereas fairness will look to make sure that there are equal outcomes for everyone in different forms, or fair outcomes for everyone. They often abstract away the actual goal of the system. And what we try to do here is to say, okay, if the goal of the system is not okay, then making it fair is not going to be good either. So we try to kind of compensate for that issue that arises in some of the fairness frameworks. Okay, so what is our proposition given what we have learned from the difference of fairness and optimization harms? So this is where we enter POTS. And POTS are very much informed by people doing things to respond to optimization systems. So one of the things people will do in their neighborhoods is report that there are blockages on their streets, or there's also a group of researchers who made it look like there is a traffic jam on the freeway by creating a bunch of ghost accounts so that Waze would divert all the traffic away from the freeway and they could have it for themselves. So we see these kind of users trying to find ways to give, let's say, unsolicited feedback to Waze so that they would reroute the traffic to other roads. Okay, so we were kind of excited about this. Here are some more examples. I think I told these two, and this is like the Miami police basically polluted the whole Waze database so that it looked like there were police controls everywhere, which is kind of scary, but okay, they did that. And if you heard Helen's talk from a couple of weeks ago, this is indeed like very close to obfuscation techniques that have been used against unfair practices in advertisement. Okay, so how would we be developing POTS? The idea is to basically use our computer science skills to systematize and make effective, or ensure that they're effective, such attempts to re-optimize the situation for individual groups of users or environments. In that sense, POTS is very similar to adversarial machine learning, but instead of assuming that the adversary is the one that is attacking the service provider, we assume the service provider is the adversary that is serving the machine learning, and that the users are the ones that need to be protected. So how would we develop a POT? You would first identify an externality. So if this is the highway and this is a city that is basically being constantly congested because Waze is suggesting the surface road, we would then imagine, this is just an intuition, a benefit function for all the entities that are affected by the system. So this would include users, non-users, and the environments that they're moving in, and see like, okay, who benefits in what way from the system. I'm assuming that benefits above this line are positive and below it are negative for people. So that means that the person who gets from A to B is like a happy puppy, gets from A to B very fast, super happy. This is the person who flew into somebody's garden because that road was actually not very safe for so much traffic. And then we would start building a system that would look to see how we can modify the input so that we could get a better or more desirable output for this, let's say, neighborhood by diverting the traffic from them. And if we want to optimize, we could also do that. Like think about what would be the fewest number of roads we would have to block so that the traffic cannot go through. Now, pods can have different goals. The one we produced, the one that I just showed, could be that everybody has the ones who benefit a lot benefit a little less. So I think this is going to sum up your questions earlier. And the ones who lose a lot maybe benefit more, or maybe there's a way in which we can have benefits more for everyone. Like in the case of Pokemon Go, it's like unevenly distributed, but maybe we can have more Pokemons for everyone. This is the protest case. It's like there's so many ways of defining social welfare. This is the case where you practically attack the users that benefit the most from the system so that they start complaining so that the company responds. This would be one way to do this. And the sabotage option is when you basically make sure the system is not giving any optimal results. Okay, how do we formalize this? Again, we're very much informed on some level by software engineering theory. We don't want to just look at the algorithm, but we want to look at the system. And when we look at the system, we think about Michael Jackson, not the dancer, but the software engineer, theorist who said that a system is, this is going to be complicated, but basically, systems exist in environments, and we build them to fulfill requirements in those environments, right? And so we're going to think about not just looking at the system, but the world in which it exists in as well. So we assume the optimization system has a number of optimization algorithms, and it has some inputs and outputs. On the other hand, we have agents. Agents could be users, non-users, environments, or other optimization systems. Agents can take actions. So this is also really important. Pods do not have to be input into the optimization system. Around the Bay Area, I heard from Deidre that people will draw big dark circles on their roads so that they can get automated cars from not entering because it looks like potholes.
I've heard that.
What?
I've heard of it.
You've heard of that? I found it. Actually, I also found an artist that does salt voodoo on cars and makes it look like they're like stripes and they can't get out. Anyway, so I'll show you all the stuff if you want to know. There's lots of good stuff out there. We assume that the agents in the optimization system exist in a world, and the world is a bunch of states. Goes from state to state every time somebody takes an action. The world is the place that we kind of imagine to have information about all the entities. But of course, the entities themselves don't have all the information, so they have partial views on which we call observations on the world. So the optimization system has an observation of the world, and each of the agents have an observation of the world. And the world changes states through basically actions of the agents. And for simplicity, we assume that one agent at a time takes an action, and then the response that comes from the optimization system. And then we assume that the optimization system will optimize for its own objective functions, and we're able to build a pod that will re-optimize for the agents that we're basically serving. So this is our idea. There are other pods in the wild. Pokemon Go users, because of the disparity of availability of Pokemons, will often spoof GPS. They will also make changes to OpenStreetMaps to make their area look like a little river or lake or park, because they're more likely to generate Pokemons then, which is really crazy news for people who build OpenStreetMaps. Uber drivers will turn off their apps asynchronously to induce surge prices. It is not always clear if this is like urban myth or reality, but I think this is something that similar things are happening so that Uber drivers try to make a better earning. We did some experiments with credit scoring outcomes to see if you can change some of the parameters of how long and how much you take out for a loan and get a yes instead of a no. Or think about a community that takes out a lot of small loans and then repays them to generally like improve the state of that community in the eyes of the credit scoring agency. Unfit Bits was an artist project, which was for people who are required by their workplace to wear Fitbits and to do exercise. They had options on how you could also change the input. Okay, so to conclude, I define optimization systems to be different from information systems in the sense that they capture and manipulate behavior and environments for the extraction of value. In the different sections, I argued that privacy in these systems is still a problem, but maybe a sub-problem among many. There are different beasts, and they all introduce externalities, and that even if you address them using, for example, differential privacy. And what is also important, I think, is that we have done a lot of work of protection in the fairness domain, assuming that the service providers are trusted. We have seen a lot of bad behavior in the last years, especially from Facebook, of manipulating results. And I think like Alexandra's work here is also very important. So we need to maybe ask questions about what kind of other models we can develop that doesn't solely depend on the service provider. And there are lots of research questions. Some of them you raised during the discussion. So what are the problems that are or can or cannot be solved with POTS or things that look like POTS? And if we can see POTS as an instance of rethinking trust models, what would be other alternative interventions? Maybe there's something to learn from other fields that we don't know. We have mostly thought about POTS for protection of fundamental rights. But you can imagine in a service ecosystem that you can have parties who are integrating machine learning from other parties, that they might also want to be able to intervene in machine learning processes. And I think in general, we're kind of asking the question, more and more machine learning service providers have this idea that they want to secure machine learning, which is like, from a security perspective, I see the value of that. But is there maybe some value in the insecurity of machine learning that we can think a little bit about? Or is there a way to pluralize service providers in some way or decision making in some way that we haven't thought about so far? Are POTS justified? When and how can they be formalized are some of the questions we're grappling with, and I hope we'll get some feedback here.
Now we have a few minutes of comments from Stephen. Yeah, if Aaron can hold his question.
Stephen will ask better questions.
Yeah, you've got a microphone.
Yeah.
You got a few minutes.
I'll try to be short so that Aaron can say more interesting comments. So I don't know much about software engineering, but I try to say a few words from a more algorithmic perspective. So when I first learned about algorithms, many years ago, obviously, things are in a rather simple environment, right? You learn how to sort a list of numbers, or we try to optimize a very simple objective function. So optimization, when we learn it, is a very simple problem. Just tell your objective function and optimize it. But one thing that that got brought up, a very interesting point in your talk, is we need to think about when algorithm operates or system operates in reality, often need to interact within a bigger environment with many people, or many different sorts of people in some sense. It could be the users that's using Waze or the platform. It could be non-users, right? So it could be like people living in different neighborhoods who may not want the traffic passing through the neighborhood. Or it could be user in a different platform. It could be I'm a Waze user, but Waze might be implicitly impacting users of Google Map through my traffic route. So I think all these factors are pretty interesting. And more generally, we would like to think about through this interaction, how do we take into account people's societal values like privacy and fairness, or sometimes incentives, right? So like. I think I like the word protective in part, and from my own research, I like to think about two forms of protections. One obvious way, when people design system, they would like to protect the system from potential malicious behavior from users, or gaming behavior, like I just learned that you can draw huge black holes on the floor so that no auto-driving car would pass through. That's pretty interesting. So when system designer design these algorithms or system, they like this kind of robustness in the first place. So it's somewhat like a protection for the system. And nowadays we would like to also think about how to protect people's values. Obviously there's privacy and fairness. And one way we would like to think about it as an algorithm person is to usually think about these kind of notions like privacy and fairness as some form of algorithmic constraint and try to solve the underlying optimization problem subject to these kind of constraints. So more interesting question somehow come up, right? As an algorithm person, the easy technical question we'd like to think about is, okay, given the constraint, I'm going to generate an output that satisfies this form of constraint while optimizing the objective. And if I have different form of constraint or different slackness in the constraints, so to speak, I can generate a family of output or a space of models that I can explore. How do we think about negotiating these kind of different trade-off or different kind of outputs to the actual stakeholder? I think these are interesting questions that go beyond the algorithm design question. Another thing I would like to think about is how do we think about trade-off, other form of trade-off, not just between different groups of people. I like the problem of thinking about how do we model this kind of algorithm interacting with many different people through environment. So we can think about modeling this kind of interaction, and there's an interesting trade-off between what I think is model complexity and also tractability. Obviously, you can keep adding elements into your model and make it more complicated and perhaps more realistic and proving more and more complicated theorems. At the end of the day, even yourself cannot interpret. But at the same time, you do want to capture some of the salient features that you want to address as. So I think there's also an interesting question, at least for a theory point of view, how to managing this kind of trade-off while conducting this kind of formal study. Okay, so I will let some more interesting people take over the conversation.
Questions?
Aaron.
Yeah, so definitely not more interesting. It was a great talk and a great commentary.
Yeah, thank you, Stephen.
These are really interesting questions. Not the ones you raised, not the ones I'm about. So I wonder, and this came up a little bit while you were talking, but how many of the issues you raised are really questions about optimization versus questions about equilibrium? Like I think that to answer a lot of the questions you're pointing to, sort of thinking about incentives really has to be, front and center. And I sort of, and that's because I sort of think that the kinds of optimization algorithms that Google has the freedom to deploy are quite limited by incentives, right? So I sort of think about these tools as helping us to find equilibria, and maybe they can have, maybe there's room for some tweaking of the optimization in that they can choose amongst the equilibria, and we can try to push ourselves towards better equilibrium. But it seems like it would be very difficult because, ultimately individual people are optimizing for themselves when they choose what app to use, to try to implement any optimization that doesn't lead to equilibrium. And so a lot of the sort of bad things you're pointing to are perhaps just properties of equilibria. And similarly, a lot of the manipulations you talked about are arising because there are sort of aspects of the larger game that are not currently in equilibrium. If I can leave my Waze app on in my car and trick them into thinking there's traffic, that's so it's not really a these seem like very interesting economic questions to me. Yeah.
Okay. Well, that's
Just Julia.
So I was trying to think through why you wouldn't use the price mechanism to make clear what the external, if there are external costs, then put that into some pricing mechanism. So you use the example of Waze, and you use the example of congestion. Well, you know, have congestion charges rather than trying to figure out the machine algorithm. If there's an organizational structure, and it made me think obviously of the enclosure movement and the tragedy of the commons. And so I was trying to find Lynn Ostrom's writings on organizational structure. Because it's the, you know, too many people putting sheep onto the pasture. It's exactly the same problem. And then enclosing smaller and smaller plots of land that they don't want people to have access to. So it seemed as though there might be, with all due respect to the wonderful work of computer scientists, there might be some role for social science.
Absolutely. Like, I mean, I think if anything, the idea is not to say, let's say POTS are technological, but we imagine that economic, political, and other mechanisms should be part of this identification of the problem, right? Like we just kind of surfaced this problem because for most people it's like optimization, what could go wrong? And we tried to kind of make it clear. And what didn't happen here, which is interesting, is that most people say it's unethical to do POTS. And then we asked them like, okay, we're just optimizing too. So you don't think the companies are unethical? Like, why do you think it's only unethical when we optimize? So it raises a lot of interesting.
It's fascinating. I love the way you said that.
Right, and for sure, I think this is like a very, very big problem. Coming from the pets background, so this is kind of the world in which I discussed it a little little yesterday. I am a bit jet lagged. So the pets community is, for example, for good or bad reasons, for libertarian and less libertarian reasons, will be very distrustful of the law and the government. So they will think about technological solutions for something that they don't expect, like the institutions to be able to provide protections sometimes. And you can see that definitely in human rights context, right? Like you can imagine when some company or some government starts using machine learning to do very oppressive things, that like technological solutions might be the only proposition instead of the economic one or the political one. And so I think we're just putting technology as a player and not suggesting that this is the way to solve. And in fact, the first paper we wrote on this was POTS, can the revolution be optimized? And it was a question mark, right? Like, and I think we can't solve optimization problems with more optimization. I actually have a doubt about whether we can do that. Yeah. Let me just see all the hands and, okay. I'll just go like this because I'm jet lagged. So
I guess I'll just come back to the earlier question of like, why are these questions fundamentally different from ones people have faced previously? I mean, certainly in since the advent of the internet, these types of things have come up a lot, like avoiding packet inspection by ISPs and traffic, whatever, quality of service types. I'm blanking on the term, but where I, give differential access to different providers to my network, right? Or, even just people like hacking supermarket, loyalty cards.
Right, yeah.
So, it seems like on one, I don't want to take away from the sort of the fact that, obviously at a technological level, these questions are really different. But is there a way to phrase this, just kind of like what Aaron was asking about, this is, there's this language of economics that seems to fit well here. What is the kind of, what is this a special case of, I guess?
Helen, could you help me? Because you've thought about this a lot, right? Like with obfuscation.
Yeah, but I think that I was going to ask kind of a similar question to Adam. So,
do you want to ask it so that I can?
Well, it's just in the marketplace. I don't know if this is similar, but in the marketplace, you always have people who say, "Use my product because it's going to give you some advantage over all those other suckers." So that's a way in which, or like finance, come and come and invest your money with us because we know how to get you a better return on your investment than that company. So, but there is something about the cases that you described that makes me feel like it's more than just giving you the edge over people who don't have the product or maybe people who have a competing product. There's something that feels unjust about some of these cases, or either unjust to the people who don't have it, or that it's damaging to some kind of societal value. And of course, I mean, it's linked to the first part of I'm still struggling with the link to the first part of the story where you're talking about the role of data and so on, so that may be characterizing it. So it feels to me like that part of the story needs to be sharpened. Maybe it's already in the longer work, but it feels like I don't have answers to that, and I would like some.
Like one technical answer you could give to like Adam's question is that sure, this stuff's been going on for a long time, but the centralization still makes, like even if you buy that, you know, these companies are still bound to implement equilibria, the centralization still makes a difference, right? Because the price of anarchy, like the worst Nash equilibrium, is different than the price of stability, the harms of the best Nash equilibrium, and centralization gives you the power to try to now select them.
Well, yeah, I guess in general scale, well, there's power and also the fact that like any like imperfections in the optimization are like replicated at scale in a way that they wouldn't have been previously, right?
Could
like,
it be there's a zero-sum aspect to this too? It's not like use my toothbrush and then your teeth will be nicer than the other person, because they could also get, but in this case, you using this product makes other people's lives worse. Like there's a very...
I think like you can look at,
It's not
about
obvious.
financial
it's not,
markets.
yeah, that's what Darren was saying, like overall traffic could get better, right? If we, with good information about which highways are congested. But, yeah.
Okay, but can I ask something? Okay, yeah, exactly, right, thank you.
Right. I just wanted I wanted to say two things. One was when we see, right, I think Helen, part of what you're saying is that there's a public or collective good issue, not just, as you said, what toothpaste you choose might affect what's available to the marketplace, but it doesn't affect other people the same way your choice of where to drive does, right? There's like different kinds of shared resource implications. And I think, like, how I choose to interact with the financial markets, right, like making my trades, etc., is both private choices, yet it's highly regulated, that we care a lot about kind of understanding some of the network effects and externalities like in that infrastructure. And I think for some of the same reasons, it's not an area where I do research, but when I think about like NASDAQ and like, I think there's something there that you might look at. And then the other thing I wanted to say is, for me, one of the things as a lawyer that's super interesting in thinking about the sort of coordination that we're used to in a fully mediated environment like the internet and bringing them out into physical places. We know, right, like the law says, okay, Facebook, you can tell people they have to use their real names, right? That this idea about being legible to the machine in a particular way, presenting yourself in a particular way. And as this stuff comes out into the physical environment, these questions about is it adversarial, right, the whole use of the term adversarial suggests that one party is the true white knight, and
right,
the other party is, right, and are you Robin Hood or are you, Jack the Ripper? Who are you in this game? Becomes really interesting, and the place, Yoshi Kono's work, and is graffiti on a traffic sign now like literally a criminal act, right? Because it interferes with the car reading the sign, and it wouldn't, right? And so I think the questions of how law interacts with these sorts of activities in physical spaces is super interesting and something we really need to keep our eye on, because if the logic of how we've dealt with it in technical spaces carries over, I think we have lots of really difficult problems and subversion of public goals in favor of private goals where we have determined public goals matter.
Right. Yeah, absolutely. And I think, yes, this is absolutely the direction we want to go, and that's why beyond privacy, right? Yeah.
Just something that Deirdre, that you said earlier, is this a temporal phenomena or problem? Because it seems to me that this conflict that you described, that there's a world designed, streets designed according to a logic that didn't anticipate an optimization algorithm, right? Maybe cities would look entirely different if we had known there can be something like an optimization algorithm in that way, right? And so I wonder if you've thought through all of these other examples, but I wonder if the externalities you described and the problem comes because there is something in the physical world designed under different premises, and in a way we would need to redesign for the presence of such optimization.
And you see people doing that with cities, right? Like on-demand light timing and things that are about using the ability to optimize, but for a public good rather than individual interests, right? Right.
And I do think that, again, like I'm going to turn everything almost that is said into research questions, because the question is like, I was very impressed by the way like all these, we said these are just economic questions, or these can be predominantly addressed as economic questions. But in fact, like how we run our cities is not just an economic question. So I think there's something about this optimization logic, and I'm not talking about everyone, that is so associated with extraction of value that also maybe pulls us to a more economic realm on things that we used to see as social or political realms. And I think that switch is not trivial, and we need to have a discussion about what that should look like. So I think that's maybe a question of like, should we be taking optimization into account where, and then when we do, how, right? Like those are different questions. Yeah.
I'd like to try and address the question that Adam asked about, and what makes this different. And I think that optimization, the problem, and here again, I would encourage you to rethink whether optimization is, to think about this, as something that might be harmful, I think is problematic, because in and of itself, there is nothing wrong with it. This is actually something that is, could be socially good. And so one question is whether, who is doing it, private or public, and if it's a governmental function, we probably want it to be informed by public interest rather than private, right? So it would make a difference, in other words, whether we're looking at Waze that is optimizing traffic, or we're looking at Pokemon. So who cares whether, who has that, right? This is like a game, right? So everyone is like,
I don't know, does everybody feel like that? No.
Maybe people do care about that, but I think that as a society, we probably care less, right? But I think what makes this difference, and optimization here makes a difference. If we optimize our social goals using these systems, this is a completely different way than explicitly deliberating about our social goals. So I agree with you completely. This is not an economic issue. It's a political issue. Whether we want to rebuild our roads, whether we want to have more cars, less cars going through this neighborhood or that neighborhood, these are political issues. We need to, now we deliberate on this because it's explicit. I think what is really interesting in all these systems that optimize is that they actually define political norms in the way they, in a dynamic way. And I think that creates a challenge for law, because we know when the norm is, we would say, this is a bad norm, this is a good norm. But what if the norm changes? I think that we've seen it yesterday about, I don't see the, about the standard of, what is a good, what would make you a better fit, right? What are the standards for a good, for doing the best, the sport or the exercise, right? It can change depending on who is in the system, because this is optimizing.
Right.
So here the norms would also change on and I think that that creates a problem that we didn't have in the past.
Great, thank you. We are beyond out of time.
I would love to thank everyone for all the valuable comments, especially Stephen. Yeah.